After learning this technique, the games you make will never be the same. State design pattern allows an object to alter its behavior when its internal state changes. We can use this technique to create a set of unique states, and the code structure allows us to control every detail of each state individually. We can use it to give a game character a set of attacks and special abilities, or we can, for example, create multiple levels for a game. Maybe we want different environment and different enemy type to appear as we progress through the levels. Or maybe you want to add an animated menu screen that appears when we pause the game. State design pattern would be perfect for that. We have this alien, it can be in idle, charge or swarm state. Each of those states will be defined independently in its own code block, and we will be pointing towards different code blocks as we swap the alien from state to state. Being able to do this is extremely powerful. We can give each state different behavior, unique animations, or we can make the game character respond to user inputs differently depending on which state it is currently in. In my implementation, each state will be encapsulated in its own class, which makes the code flexible and reusable. Separating the logic for objects' behavior into different states makes the code easier to understand, maintain, debug, and expand. In this project, I will have a parent alien class, and I will extend it into 3 state subclasses: idle, charge, and swarm. This code implementation has elements of state design pattern as well as finite state machine. State design pattern is mostly about self-contained unique states, and finite state machine is about the relationships between these states and how they transition into each other. Click the like if you are ready to bring your game development skills to the next level. I will be using plain vanilla JavaScript and object-oriented programming with no frameworks and no libraries as usual, but if you want, you can also easily convert this into a different programming language, since I'm only using generic tools like functions, arrays, and for loops. Most programming languages have these. I have a basic animation project set up here. Index.html file where we link style sheet and script file. I give my script the defer attribute, which means it will run this code only after the core content of the web page has loaded. I also create a standard simple canvas element here. In CSS, we just centered the canvas, and here in script.js, we run the usual 4 lines of code to set the canvas up. I can test if everything works by setting canvas font to 25 pixels impact, and I call built-in fill text method, and I pass it text I want to draw and x and y coordinates of an anchor point in relation to which I want the text to be drawn on canvas. Nice, we are ready to draw and animate. I will have a JavaScript class for my alien, and I will create a main game class which will manage the state of the entire project. All the logic will be controlled from here. Constructor will expect canvas as an argument, and from here we will extract its width and height properties because I want width and height of the game object to be set to the same size as canvas. I also create this.alien property, and at first I will set it to new alien, to an instance of alien class we defined on line 7. My alien will have x and y coordinates so that JavaScript knows where on canvas we want to draw it, and it will have width and height. I give it a draw method which will expect context as an argument because I don't want to be pulling global variables into my classes directly. And I call fill rectangle method to draw a black rectangle representing the alien. This code will run automatically when we create an instance of game class in a minute, which means that alien class will be instantiated automatically with the game class here. I give game a render method, and again it will expect context to specify which canvas to draw on. From inside render, I will draw all my game objects. For now, we just have the alien, so I take this.alien from line 24 and I call its draw method we defined on line 14, passing the context reference along. Now, let's test if it works. I create an instance of game class. I can see it expects canvas, so I pass it canvas variable from line 1 as an argument. Now I take that instance and I call render method from line 26. It expects drawing context, so I pass it ctx from line 2. Nice, we are drawing the alien. I can change its x and y coordinates and its width and height. It works. We have access to alien from inside the game class. I want to establish a two-way connection between these two classes because I want to be able to see properties and methods that sit on the game class from inside the alien class. I pass alien this keyword here, representing this entire game object with all its properties and methods. We will expect that reference here, and inside I convert it into this.game property, which will now point to the space in memory where the main game object sits. When anything changes inside the game class, it will be immediately visible from inside the alien class as well. I can test the connection by accessing with property on the game class from here. I center the alien in the middle of canvas horizontally and vertically. Rectangles on canvas are drawn from the top left corner, so to center it exactly in the middle, I have to declare width and height first, and then I offset this.x and this.y by half of alien width and by a half of alien height, like this. When we do this, it will always be centered, no matter which width and height we give it. Perfect. We will control the alien using a keyboard, so let's keep track of which keys were pressed and released here. I set it to a JavaScript set, like this. Set in JavaScript is an object that allows us to store unique values of any type, and the main thing is that each value in the set may only occur once. Each value must be unique in the sets collection, which is perfect for this use case, because if we hold a key down, I don't want to be adding the same key multiple times each time the key down event fires. It will be added only once, because the set doesn't allow copies of the same value. All the code inside a class constructor is automatically executed when we create an instance of that class, so I can put any code I want in here. I can even declare event listeners, and putting them here means they will be automatically applied when an instance of the game class is created. I create an event listener for key down event. I console log the auto-generated event object, and I'm looking for this property, so e.key. Now we are getting the name of the key we are pressing. I take this.keys and I call built-in add method, which inserts a new element with a specified value into a set object, if there isn't an element with the same value already in the set. If I console log this.keys from here and I press some random keys on my keyboard, I can see they are being added into the set, but we never get any duplicates. Great. One more event listener, and when a key is released, I will actually just clear, which removes all elements from the set object. We can now press one or multiple keys, and they are added to the set, and when I release any key, the entire keys set is cleared. So how do we implement state design pattern in the codebase? We have our main alien class, which will contain properties and methods shared for all alien states. I will then extend that class into multiple separate subclasses. Each state will be a separate subclass, extending the parent alien class. This will allow us to put any kind of separate logic, behavior, and animations for each state. And at the same time, we are setting up prototype-based inheritance by extending the alien superclass, which means that if we don't define something on the subclass, it will just fall back to the defaults defined here on the alien parent class. Let's see how that works exactly. We have alien parent class, also called a superclass, and we are extending it into 3 separate child classes, also called subclasses. We will actually never instantiate the main alien class. It's here just to create the base prototype, to define the shared properties and methods. Alien will always be in one of the 3 states: idle, charge, or swarm. And I will swap between these 3 states by reassigning this.alien property here to one of these 3 subclasses. Because of how prototype-based inheritance works and how all these subclasses fall back on the main alien class, it will work very well for us. Let me show you. Game is our main state management object, so I will swap the states from here. I create a property called alien states, and it will be an array. Inside, I instantiate all 3 subclasses: new idle, new charge, and new swarm. and I will set this.alien to alien states index 0 at the first page load, for example, which would be the idle state subclass. We get an error, and that's because I'm no longer instantiating alien, so it needs game reference to come from somewhere. I will pass this keyword to all state subclasses. This keyword is a reference to the entire game object. Since our subclasses don't need to have a constructor, JavaScript will follow the prototype chain that we set up using the extends keyword, and it will find the constructor method on the parent alien class. It will pass this keyword as game reference here, converting it into this.game property, and now it all works again. It's the same with the draw method. I'm calling draw method on this.alien, which is an instance of idle subclass. This subclass doesn't have draw method defined, so JavaScript will automatically go up the prototype chain and it will find that method here on the parent alien class, on the superclass. It's very important to understand this concept. Let me know if you have any questions in the comments. Now you might be thinking that we need to give each state subclass a constructor because we might want to give each state a different set of properties. But what I will do instead is that I will declare all properties on the alien parent class, and we will give each subclass a setter method. I will call it, for example, start. This method will run automatically once when we swap alien state, and it will set properties on the alien to whatever value we want them to be while we are in this particular state. So each subclass will have its own unique start method, but all the properties will be stored on the shared parent alien class, and we will set those to different values as we swap states. First, let's try a very simple and very visual example of how this will work. Hopefully this will clarify things even more. I want to draw this black rectangle in a different color when we swap from state to state. This dot color on the parent alien will be green. It doesn't really matter what value we give it here, because we will never call this alien class directly. We will always call one of the subclasses. This draw method will be shared for all states. I will simply set fill style to this.color. Start method will always run first when we swap to a particular state. We will write that logic soon. When we enter idle state, I want the color to be red. Charge will be green and swarm will be blue. We have three states: idle, charge, swarm. Red, green, blue. Here I set this.alien to alien states 0 to idle, and then I call start method from there, which will run the code we defined here on line 23. We can see that worked because the alien is red now. I call charge, element with an index of 1, and this will give me green. 3 will be an error, we don't have that element in the array. Element with an index of 2 is swarm. Indexes start from 0, so 0, 1, 2. I'm sure you know that. So we have the game class. This is where the state of the application will be managed. We have alien parent class that will be extended into 3 separate subclasses. Each subclass represents a state the alien can be in, and we can put any properties and methods on each of those subclasses. We can go very deep, unique and specific for each state separately. I like how it's all organized in separate blocks. It makes the codebase easy to navigate in, and if we encounter a bug, we just check which state we are in when the bug happens, and we know we have to go to that particular code block to fix it. This demonstrates how the state design pattern makes our code modular, easy to expand, and easy to debug. We need one last piece to this logic. We need a method that, when called, it will switch alien to a different state. We said that the state of the application is managed from the main game class, so I put that custom method here. I call it setAlienState, and it will expect state as an argument. This state argument will be a number, either 0 or 1 or 2. Then we take this.alien from line 45 and we assign it to that particular object. It will be this.alien states 0 or 1 or 2. Once we switched to a new state, we call start method to set all properties to the values they need to be. Right now we are just swapping to a different color there. So the way I implemented state design pattern, we are pointing this.alien property to a different state subclass. Each of the subclasses contains some unique properties and logic, and they all extend the base alien superclass that contains all the shared methods and properties. We call set alien state, we pass it 0 for idle, 1 for charge, 2 for swarm. The method will assign this.alien property to that particular subclass, and then it will call start method that sits on that subclass. Here we call draw method on this.alien. We will also call update. Update method is important. It will define behavior of the alien while in each individual state. So we will have a different update method on each subclass. When in idle, I will console log idle. Here on the first page load, I set it to index 0, and we can see idle in the console. As we swap from state to state, different update method will run, and we can put unique logic in each one. It will be easier to test this if we are animating. I create a custom function I call animate. Inside, I call render, and then we call request animation frame, and pass it animate again, creating an animation loop. I call the first loop here to start animating. Between each animation frame, we want to clear the entire canvas from the old paint, so I call clear rectangle, and I clear the entire canvas area. So we call render method from inside animate, and in there we are calling update method. There is a different update method on each state object, which means we can give each state completely separate code, changing its behavior as we change states. In idle state, we just console log the word idle. In charge state, I can, for example, increase the horizontal X coordinate by 1 pixel per animation frame, making it move to the right. Here on the first page load, I can test it. Index 0, and we get the console log. Index 1, and we get the movement. Index 2, the swarm state has no code inside its update method, so nothing is happening. We have this .keys array, and we add and remove keys as we type, and key down and key up events trigger. I can, for example, change how the alien responds to user input based on which state it is currently in. I can make alien react to the same key differently depending on which state it is, or I can make it react only to some keys and ignore some keys while in specific states. While in idle state, we can check if number 2 was pressed. We know that this.keys is a set object. I can call built-in has method that returns a boolean, true or false, whether an element with a given value is present in the set or not. If this.keys set has number 2, if we pressed 2 on the keyboard, we call set alien state, and we pass it 1, charge state. Else, if we press 3, we set alien state to index 2, the swarm state, for example. I test it. I get an error on line 27. I check that code block. I see this.keys set sits on the main game object. I need to call this as this.game.keys, like this. Now we start in the red idle state on the first load. If I press 2, we switch to charging state, and line 39 will make the green alien move to the right. I reload the page, it will reset back to the red idle state, and its update method allows us to press 2 or 3. So I press 3, which will switch me to the blue swarm state we defined on line 42. I want the alien object to react to different keyboard inputs in different ways, always depending on which state it is currently in, which update method is being called as we swap alien object between idle, charge, and swarm. While we are in the charge state, we can only switch to swarm state by pressing number 3 on the keyboard. Pressing 1 or 2 will do nothing here. So I reload the page. By default, we are in the red idle state. I know I can press 2 to switch into green charge state, and in there nothing happens as I press keys, unless I press number 3 on my keyboard, which will switch the alien into the blue swarm state. Let's console log this.keys array here, so the console shows what I'm pressing on my keyboard, as you can't see my hands. I copy this code block, and now I want to define behavior of the alien while in the swarm state. We press 1 while in the swarm state, the alien will switch to idle. If we press 2, it will switch to charge. Pressing 3 will do nothing while we are in swarm. Cool, so we defined how we want the alien to behave while in each state. I reload the page. It puts us back to the default red idle state. This is the currently active update method. And as you can see, when I press number 1 on the keyboard, nothing is happening. If I press 2, we switch into the green charge state. It would make sense to create an enum object somewhere that translates these 0 and 1 and 2 values into actual words like idle, charge, and swarm. It would make the code easier to read because now I have to remember which indexes we have in the array every time I want to call setAlienState method. Okay, we swapped into the green charge state, and this update method is active now. If I press 1 or 2, nothing happens. This method will only react if I press 3 on my keyboard, and it will set alien state to swarm. We are currently in swarm state, which means this method is active. Now if I press 3, nothing will happen. But as soon as I press 1, we switch to the red idle state. This is very useful because, for example, you might not want the player to be able to switch from one state to another until animation sequence finished playing or something like that. We are in full control now. We can put any code we want inside each update method. We can do many different things with this code structure now. I can, for example, give alien a counter. Initially, I set it to 0. And I also give it max count, and I set it to 200. When we enter charge, I reset counter to 0 in case it was counting before, and in the update method on charge state, I will increase counter by 1 for each animation frame. I will console log this.counter here, and I say if this.counter is more than max count, more than 200, call setAlienState automatically and switch alien to the red idle state. So we are in charge. We can press 3 anytime to manually switch to swarm, but we can't switch to idle anytime we want. Alien is moving very fast and it cannot stop. Let's say it can have some momentum. If we enter charge state and do nothing, the counter will keep increasing to 200 and it will switch the alien to the basic idle state automatically. Maybe the alien gets tired and it can charge only for a limited amount of time. We could also increase max count as we play the game, giving the alien more stamina, which will allow it to charge longer eventually as the game goes on. In a game, I would probably use delta time here to count actual milliseconds, but for this example, we are counting animation frames and that's fine. I reload my page, we are in the default red idle state. I can see that I can press 2 to charge. When I press 2, we switch to the green charging state, counter resets to 0 and starts increasing by 1 per animation frame. When the counter reaches 200, it will automatically switch back to idle. Now we have a way to switch state based on player input manually and also after an automated condition check with the counter. I could, for example, create transitional states where alien animates from one state to another, and I can just enter that transitional state, run a series of animation frames, and when we reach the last animation frame in that particular sequence, I can automatically switch the alien to the next state that follows. We have the parent alien class and 3 subclasses: idle, charge, and swarm. We are never directly calling the alien, we are always calling one of the 3 subclasses. We are calling draw method on idle state now, but since there is no draw method declared there, JavaScript knows to follow the prototype chain and it will find the draw method on the parent alien class and it will draw it from there. In some states, I can intercept that chain and I can replace that draw method just for that state, leaving the other states intact and let those fall back on the default. I do it here. Let's say when we are swarming, I want to draw multiple aliens. I also want to draw the main alien, so I will still first call the draw method we defined on the parent alien class, also called a superclass. I call it using this syntax, super.draw, and I pass the context along. This line will first run all the code inside the draw method we defined on line 18, and then I can add some additional code here on top of that. For example, I will draw another rectangle. I reload the page. We are in the default red idle state. I know I can press 3 to switch to swarm, and that will take us here. And now we are drawing that big blue alien and also a smaller alien we defined here on line 65. We are in the swarm state, so I know I can press 2 to switch to green charge state. While in charge, the counter is increasing, and when it reaches 200, it will automatically switch to the red idle state. I will delete this draw method. I just wanted to show you what was possible. If you understand prototypes in JavaScript, this should be clear. Now, again, there is no draw method on swarm class, so it will automatically fall back to the draw method from line 18. This is the most simple implementation of state design pattern I could come up with today. That would be useful for us in the next game we are about to build. I hope it makes sense. I think it might be a bit of a challenge to keep track of everything if you are a beginner. It becomes easier as you write more code and practice. We can use this state pattern not only to change alien states, we can also use it to switch the game to different levels, to invoke menus, things like that. It's incredibly useful and powerful. Maybe I want to create a separate state for each level, and each level will have unique environment, enemies, and the player might look different and it might evolve through the levels, which is what we will do in the next game when we focus on player mutations. Let's give the user some helper text that will change depending on the alien state. I create a paragraph element with an ID of info. I bring it into the project as this.info property on the main game class, and I point JavaScript towards it using its ID. Then we set alien state. We will also take this.info and we will set inner text value of that paragraph to text property on this.alien. In idle, text will say idle. In charge, it will say charge. And here it will say swarm. I adjust this code. I just define alien property, but I don't give it a value yet. Whenever I reload the page, it will be given a value here by calling this.setAlienState. 0 for idle. Notice how the text is changing. 1 for charge, which will count and automatically switch to idle later. And 2 for swarm. In style CSS, I can center the paragraph and maybe make it larger. Now that we have this text, we can use it to give the user more information about each alien state. I want to combine text and variables here, so instead of usual string concatenation, I can use so-called template literals, also known as template strings. These allow us to interpolate strings and insert variables or expressions to evaluate directly into the text. They are commonly used in modern JavaScript. If you are following and coding in another programming language, you can just use the regular string interpolation here and connect text and variables with a plus sign. For template literals, instead of quotes, we use backticks. I want the text here to say charging, press 3 to swarm, or wait for the counter to reach max count value to automatically switch to idle. The syntax to include a variable here is a $sign and brackets like this. Easy. I reload my project. I press number 2 to switch into the charging state, and we can see the message. Then it automatically switches to idle as we designed. Perfect. I will actually use the technique we already explained, and I will define draw method here on the charge state. First, I want to call the draw method from line 18. So I say super.draw, And then I add a little bit of code. I want this to run only while the alien is in the charge-in state. I want to call fillText method and pass it this.counter, and I want to draw it at coordinates 15, 30. I reload my project. I press 2 to switch into charge, and now we can also see the counter. Nice. In idle state, I want the text to say press 2 to charge, or 3 to swarm. While we are in swarm state, the text will say press 1 to idle, or 2 to charge. And also, we will tell them we are currently in the swarm state. And here idle. Okay. On the first page load, it will start in idle. While in idle, we know we can press 2 to charge and 3 to swarm. Pressing 1 does nothing here, so I press 2 and I charge. And we know we can interrupt the charge by pressing 3, which will switch us to the swarm state. Or we can let the counter to play out and set us back to idle automatically. I press 2 to charge. Now, while in charging, I press 3 and we are swarming. While in the swarm state, pressing 3 does nothing. The alien will only react to 1 or 2 being pressed. Okay, so state design pattern. Very simple, basic implementation, but it can still be a challenge for beginners. So well done if you followed all the way here. We have a basic alien class that holds all properties and methods shared among all state subclasses. We never instantiate this class directly. We will always instantiate one of the subclasses that extend it, because the alien is always in one of the states, in idle, or charge, or swarm. If JavaScript can't find draw method on swarm class, for example, it will follow the prototype chain and it will find that method on the parent alien class. We instantiate all alien states here and put them in an array. Here we define this.alien property and we point that property to idle, charge, or swarm as we set alien state using our custom method. Then we call update and draw from that alien. So when we swap, different update method is called and even different draw method if we decided to give a state some special draw logic, like we did with charge this time to draw the counter text. Update method will have unique logic inside for each state. In this case, they change what keys the alien reacts to while in different states. Here we also have that unique draw logic where we first call the code inside the draw method on the parent alien class, and we add a little bit of code specific only to charge state here. Now let's actually animate the alien and use state design pattern to switch between different animations. I created a special sprite sheet for this class. You can take it and use it in your own games if you want. You can download it in the resources section below as usual. I put the image in my project folder, I import it here in index.html and I give it an ID of locustmorph_large, because I will probably also give you a regular smaller version that you can use in Space Invaders or Planet Defense games we built before if you want. Let's see. I need to come up with some unique behavior first. I'm thinking this through as I'm recording this. I will hide the image with CSS. I'm giving my script tag a defer attribute to make sure the image is loaded in memory before we run any JavaScript code that depends on that image being available. I create this.image property. I point it towards this image using its ID. I can do it from inside the shared draw method. I call built-in drawImage method. I pass it the image I want to draw and X and Y coordinates where to draw it. Now we are just drawing the entire massive sprite sheet. I will use this.x, this.y here. Sprite width, the width of a single frame in this sprite sheet is 360 pixels. Sprite height, the height of a single frame is also 360. Then I set width and height to these same values, but keeping these separate allows for scaling if I want to do it later. We will use these two to crop individual frames from the sprite sheet and these two to draw them at that size on canvas, so they don't necessarily need to be set to the same value. It depends on your project. I can pass drawImage optional width and height, which will just stretch, or in this case it will squeeze the entire sprite sheet with all its frames into that predefined area. We actually want to crop out individual frames and travel around the sprite sheet. We need the ultimate control, so 9 arguments. Image to draw, source X, source Y, source width and source height will define the area we want to crop out from the source image. And destination X, Y, width, height will define where to draw that cropped out piece on destination canvas. Source Y argument defines the vertical cropping coordinate, so 0 times the height of a single frame is this row, 1 times sprite height is this row, and 2 is this row. I will call that multiplier frame Y, and we can see that because of how I chose to organize the frames in this particular sprite sheet when I created it, row 0 is idle animation, row 1 is charge animation, and row 2 is swarm animation. I define frame Y here. When we enter idle, we set frame Y to 0. In charge, we set it to 1. And in swarm, we set frame Y to 2. Now, as I swap between states by pressing 1, 2, 3 on the keyboard, we can see it jumps to the correct row in the sprite sheet. I actually don't need the background rectangle anymore. Our aliens now evolved from simple rectangles into proper detailed space creatures. I could also give the canvas some nice space background if I want to. You have plenty of those if you followed the other episodes in the space series. Source X argument passed the drawImage method will define the horizontal cropping coordinate. In this case, traveling around the sprite sheet horizontally will actually play the animation sequence and it will finally bring the alien to life. I made this sprite sheet using Dragon Bones software, in case you want to know. Frame X will start at 0 and we use it here. Now I need to cycle between 0 and maximum horizontal frame over and over to animate this. I could put that logic into update, but I would have to refactor my code a little bit. It doesn't matter much for this demo. I will use ternary operator as a simple one-line if-else statement. Expression to evaluate, if true, question mark, do this, else, colon, do that. If frame X is less than max frame, question mark, keep increasing frame X by 1 per animation frame. Else, set frame X back to 0 so that it can cycle again. Now I can define max frame. If I use a number that is too high, we will get blinking because we are including empty frames. If I use a number that is too low, we will play only a part of the animation and the loops will not connect. In this sprite sheet, I have to use 38. Alright, let's do this one last time. The alien is in the basic idle state. I know I can press number 2 to charge. We are charging, we are playing a different animation. When the counter reaches 200, we will automatically switch back to idle because of the logic we wrote on line 57. When in idle, we can also press number 3 to swarm. While in swarm, I can press 1 to go back to idle, and if I press 3 when in idle, we go back to swarm. Now I'm in swarm state, so this update method from line 72 applies. I press 3 to go from idle to swarm, 2 to charge. While charging, I press 3 to interrupt the charge, 3 to swarm, 1 to idle, and this update method takes over. I'm using these separate update methods to apply a different set of controls for each state, but you can do literally anything here, depending on how you design your game. The alien could be evolving from state to state, gaining new attacks and abilities as it mutates and grows, for example. This technique is so powerful, and it gives us the ultimate control over the state of our game character, or even of the entire game. Because I can create separate states for each level and have different enemies, environments, and other unique features assigned to each level using this code structure. I want to use this in an actual game project now. I'll go and design something, and if you want to see what I came up with, I will see you in that next video. Let me know how difficult you find the codebase and the concepts we covered today. 1 is extremely easy, 10 is very difficult. Leave a comment with a number so I know if I should explain it in more detail, or I can go a bit faster next time. Click the like if you found some value. Thanks, see ya!